Okay, so this is day 3 of our review. If you haven't done day 1 and day 2, please go back and do those first. You want to make sure that you're doing every problem every single day so that you're kind of keeping track and you're going to be ready for the final so you can get the best grade possible. Let's look at these systems of equations right here. When I look at this, it looks like I could add straight down and use elimination, but the issue is that's x and that x would not cancel. So what I would do is I would flip all the signs on the bottom. So I'm going to make that a negative. I'll make this one a negative too, so we'll kind of erase that and make that a negative. And since that's already negative, we'd make it a positive. We then add straight down, so that's going to cancel out. That's going to give me negative 3y, and this is going to give me 9. We would then divide both sides by negative 3, and I'd get y is equal to negative 3. Well, now that we have the answer of negative 3, what we're going to do with this is we're going to plug it into one of your two equations. I'm probably going to plug it into my top equation, get negative 3y, negative 3 plus 4y is equal to negative 3. I would then add 3 to both sides, which would give me 0. When you divide by 4, you just get y is 0. So those would be my two answers. Y would be 0, and x would be negative 3. Let's try the next problem. Okay, so for this one we have to decide where it's increasing and decreasing, and specifically we have to decide where it's decreasing. So you can see on this one, the only time it's decreasing is this line right here. And you'll get to see a lot of options for this, where I include some x's and some y's, but really if you remember, y's are not very good at explaining things because if you're thinking x's are like more constant, y's like vary more with the graph where they go up and down, but it always just kind of goes like this for the x's. So we like to use x's because they're more consistent. So I just use the two x values and I know it's decreasing from negative 1.786 to 1.12. Okay, so that's where I get my point from. And again, you want to use parentheses. You'll always use parentheses for these increasing and decreasing problems and these positive and negatives because this point right here isn't really decreasing or increasing, and this point isn't really decreasing or increasing, so you don't get to include them. Let's try the next one. Okay, so for this problem, they want to find a maximum revenue and a maximum product. So if you want to find your maximum for certain things, if you look, there's our function. And so when I see that function, I go, oh, I know what that is. That thing is a quadratic. So that's the first thing that goes through my head is I go, oh, I know that's a quadratic. And if I want to find a max, that is my max. And I go, oh, how do I find a max given a quadratic? Oh, that's the same thing as a vertex. And I know how to find a vertex. That's just negative b over 2a. So we kind of just think through the process of how you do each step. If I want to find that vertex point, my b term is 300. So that would be negative 300 over, well, 15 times 2 is negative 30. And so we would get this to be 10. So that is my maximum for my x value, and your x value here is p, which should stand for product. So my product is 10. So we would say that our product is 10. Let me just put that there. And now you have to find a y value. So finding a y value means we take this and we plug that in for our different p values. Whoops, there's no p value there. So you just plug it in for your different p values. I like to use a calculator to do this. And what you can do is just type in, whoops, negative 15, 10, I forgot to times 10 squared plus 300 times 10 plus 1200 or 12,000, and you would see that we would get our answer, which is 13500. Okay, So that's how I would do that problem. Let's try the next one. Okay, so your vertex for this problem should be really easy because you should know that this is your slope, this is your x movement, and this is your y movement. So your vertex is that like bottommost point, or how much they like shifted over. So they've shifted this -9 spaces because it's to the left -9, and they've shifted it down 5. Now your y-intercept, you should also be able to think through and be like, oh, a y-intercept is where it hits this axis. And so if you think about what a y-intercept means, is like if you have a U shape and it's going to hit that axis, I don't know anything about the y value, but I do know that the x value would be 0 because it's on this line. So for this y-intercept, I know that my x value is 0. And so if I know my x value is 0, I can just plug in 0 here. So then we could use our calculator again to figure this out. So that'd be -2, 0 plus 9 squared minus 5. And we would get that our y-intercept is -167. And that would be my final answer for this. Let's try the next one. For this one, we want to find our quadratic term, our linear term, and our constant term. Where you find that is in the form ax squared plus bx plus c. That's your quadratic term since it's in front of your quadratic number. That's your linear term because it's in front of your linear number. And that's a constant because it doesn't have an x by it, so it doesn't have a linear thing with it. So now this is not in the correct form. So we need to put it in the correct form because it's in vertex form. So to do that, we need to deal with that squared number. So we would write -2 x minus 1 squared minus 1. We would square this thing, which means we'd have -2 x minus 1 times x minus 1 minus 1. We would then deal with that by distributing. So I distribute, whoops, I did my distribution a little off. I want to go there, and then there and there. So we would get this to be -2 x squared minus 1x minus 1x plus 1 and minus 1. Then we'll distribute this -2 to everything inside there. I'll add that together because I know that's 2. So that's going to be -2 x squared plus 4x minus 2 minus 1, and we would finally get -2x squared plus 4x minus 3, which then my quadratic term would be -2, my linear term would be 4, and my constant term would be -3. Just make sure on this problem that if it's not multiplied out, if it's not multiplied out, that you multiply it out so that you can kind of see it in standard form. We can only find its quadratic term, its linear term, and its constant term in standard form. Let's try. I need to write line equations for these two things. So first I'm going to write line equations for this bottom one. It starts down here at -3. So let's put that in. It starts down there at -3. Its slope looks like it's going up 1, 2, 3, 4, and over 1. So it'd be 4x. And then I'd say we have a y. This is a dotted line, so it's going to have nothing underlined for it, and it looks like it shades above that line. So we're going to write that right there. This is my second line, so let's see where that starts. That starts at +3, and it looks like the slope is down 1, 2, and over 1, so that'd be -2x. And now for the sign, we know we're going to have an underlined because this is a solid line, and this one looks like it is also shading up. So that would be greater than again. So this would be my equation. Okay, we're going to graph this absolute value. Again, you should go, oh, this means it's going to start up 5, and it's going to start left 2. because again, this is opposite, so we're going to shift our thing and we're going to go left 2 and then up 5. So we're going to go left 2, up 5. There's my starting point. Because this is an absolute value, it's going to make some kind of V shape. So there's my V shape. I made a tiny mistake because this is just strictly greater than, so this is a dotted V shape. And because it's greater than, we're going to shade above. So we're going to shade in this region right here that goes above, right like that. So just make sure, again, you want to make sure your sign is facing the right way. You have it correctly dotted or solid. And then you want to have it shaded based on greater than or less than. And again, this is always opposite. This is your y value, so it goes up and down. Try that. Okay, so this one's pretty easy, because what you should think about roots is how do you find roots? Most times you find them with the quadratic formula. So if you have a positive square root, you would also have a negative square root. So your other one would be 3 minus radical 2. Make sure you include the 3. Like, see how this is a root? It doesn't say these are two separate roots. Like, I'm not trying to be fancy here and saying that's a root and that's a root. Like, this whole thing is a square root. So because that whole thing is a square root, you have to use that 3 also here. Let's try the next one. This problem kind of piggybacks off the last one. So you should go, oh, an imaginary number is the square root of negative 1. So I found it by doing a square root. And generally you find these things using the quadratic formula, meaning this has a plus or a minus. And so because this has a plus and a minus here, if you're looking for your imaginary roots for a 5th degree polynomial, you should be thinking, oh, like we can go up to 5, but because I have a plus or minus, these should come in pairs. So because they come in pairs, you can have at most 4, because that would go over the number of roots if you had 6. Then you could have 2 or 0. You can't have 5 imaginary roots because then it wouldn't come in pairs. Okay, so when I'm thinking of my imaginary roots, what I'm looking for is we're looking for an even number, and we want to count until we get to that number, or one less, depending on if that number is even or odd. If I wanted to know, so this is my imaginary roots, and that's what I was asking for. If I wanted to know my real roots, we use our imaginary roots to get to 5. So this is 1 off of 5, so then I have 1 real root. This is 2 off of 5, so I have 3 real roots. And if I had 0 imaginary roots, I'd have 5 real roots. Your imaginary roots and your real roots always have to add up to the degree of the polynomial. So your polynomial degree will be the number of roots that you have. Imaginaries will come in pairs. Real numbers don't have to come in pairs because of different reasons. So we're going to try the next problem. Just make sure you know how to do this combination. Okay, so for this next problem, we have x cubed plus 8 equals 0. And when we're looking at this, the first thing that we can try to do is we could try to just solve this like normal, since we go, oh, it has one variable. So maybe you go, I'm going to take this, and I'm going to minus 8 on both sides. So I'm going to get x cubed equals negative 8. And then I'm going to take its cubed root, and then I'm going to get x equals 2, or negative 2. But you should realize with this that this thing is a cube root. So cube roots, or this is a cube, so cube should have 3 zeros. We just got 1 with no way to get another one. So you don't really want to use this method to try to find all the solutions to this thing. What you want to use is you want to use the sum or difference of cubes. And if you remember that formula, that's a plus b times a squared plus ba plus b squared. And the important part to realize is how this kind of makes up and works. Like if you think about how you would get a cubed, well, you would take, or x cubed, you would take x times x squared. See how that way I'd get a cubed? Oh, I messed up a little bit on the formula. There's a, instead of that being a plus right here, that's a minus, so you'll get things to cancel out. And then the other thing is, if you think about how to get 8, you don't want to put 8 here, because if you put 8 here, that would be 8 times 64, and you get a really big number. Like, you want to get to 8. So if I'm thinking about how I would get to 8, I would do 2 times 2 squared, which would be 4, and 2 times 4 is 8. So your A in this case is x, and your B in this case is 2. And we get that by thinking about what could I multiply by itself 3 times to get to this, and what could I multiply by itself 3 times to get to that. Then we plug all that stuff in. So this over here now would be x plus 2 and x squared minus 2x plus 4. Now this part, since this thing is equal to 0, we can solve really easily. We can just subtract 2 from both sides and get that as an answer, which we already got over here. This one takes a little bit more work. We're going to need to use the quadratic formula on that one. So because we're going to need to use the quadratic formula, all you're going to have to do is plug it into this thing, which I'll write it over here, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So now we're going to plug that in. That's going to give me the opposite of a negative 2 is a positive 2. This is going to give me b squared, which would be 4, minus 1 times 4 times 4, which would be 16, over 2. Well, now we can get this a little bit nicer, and I can get this a little bit nicer by subtracting that, and 4 minus 16 is negative 12. And now you could, normally we could stop here, but on the test they're going to make us simplify this just a little bit more. So if you think about what makes up negative 12, it's made up of negative 4 and 3. And the square root of negative 4 would be 2i, and the square root of 3 is just the square root of 3. So this would be 2 plus or minus 2i radical 3 all over 2. And now you can get 2 to divide both those things. So you're going to end up getting 1 plus or minus I radical 3. And that would be your final answer, along with your negative 2 that we had up there. So you can see this is, if I just kind of zoom out, it's a little bit of an involved process, but just make sure you do the different elements of each thing. Like, use the formula, make sure you find the correct A and B, plug everything in, and use the quadratic formula to find your 2 answers. Okay, so for this one, let's factor it completely. Again, this acts like every other factoring problem. You want to try to multiply together to give you this, and add together to give you this. The reason why you know that's going to work is because it fits this mold of 4, 2, 1. That same mold fits for 2, 1, 0. Like, what happens in that mold is every time you're cutting the things in half, like half, half, then it goes to 0. Same thing with this one, 2, 1, 0. You could do the same thing with 6, 3, 0. Every time it's cut in half, you can use this pattern of it should multiply and add. So now we just have to make sure it works. That would be x squared. That would also be x squared. That would be, what do we need to multiply together to give us x to the to 4? Well, that would be 4 and 1, because it's got to add together to give us 5. So 4 plus 1 equals 5. Well, that's a negative 5, so let's make them both negative. Okay. So again, we got our x squared because we need to get it to x to the 4th. Now, if you left it like this, you're wrong, because that's not factoring completely. Because sometimes you can factor this. So when I look at that, I know that I can factor that because there is a number that will multiply together to give me 4 and add together to give me the missing term, which is 0. So that would be x times x, and then negative 2 times positive 2 would get me to negative 4 and add together to give me 0. Well, if you saw the pattern that worked for there, this pattern would also work, because now I have x minus 1 and x plus 1, and that would equal 0 and multiply together to give you negative 1. That is factored out completely now. Let's try the next one. This is really similar to yesterday. We're just going to distribute. I'm going to get negative 8 minus 2i minus 4i minus I squared. That's going to be negative 8 minus 6i minus I squared. We know what I squared is. It's negative 1, so it's going to flip that sign. So we're going to get negative 8 minus 6i plus 1. And I know a positive 1 and a negative 8 is going to give me negative 7 minus 6i. And that would be my final answer. Those are how you do all the problems on the video today. If you get stuck with anything, please let me know, because I'm going to be, I can try to help you with it. If you haven't finished all the other things, you really do need to finish this. You really need to take the time and sit down and try every problem and figure out which problems you really can do and which problems you're going to struggle with. And it's okay to not know every single problem on the final, but you want to know enough that you're going to get a good score. So you do have to have that balance of which problems can I kind of skip and not be as familiar with, and which problems do I need to know really well so I can get them right. Okay? So let me know if you have any questions, but that's it for this one.